Hi, in 8.5 we examine three theorems that involve proportions. The first of the three is known as the side-splitter theorem. It reads, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides proportionally. Here I've created a sketchpad demonstration for you. So I created a random point, and it doesn't have to be the midpoint. It can be anywhere on the side of the triangle as long as the gold line is parallel to one of the sides of the triangles. Then you can see I've measured AB and BC, and when I divide AB by BC, I get this number, and AD and DE, and that ratio is that number, and those numbers are equal. It doesn't matter where that division occurs. Those numbers will always be the same. It doesn't matter if the triangle is acute or obtuse. I hope I'm not out of the frame. Or even, can I fake a right triangle? So those numbers will always be the same. So let's look at a couple of examples. On this first example, we are told that BE is parallel to AT. That means CB is to BA the same way that CE is to ET. We are given that CB is 3. We are given CA is 10. So I'm going to need to subtract 3 from 10 in order to find out the length of BA. And then CE is 6, and I'm requested to find ET. So now I can say 3 is to 7, the same way 6 is to X. I use the means extremes product theorem, and then X is 6 divided by 3 is 2, times 7 is 14. On this example, we are asked to find the length first of ED. So here I can use the side splitter to say that 4 is to 2, the same way 7 is to A. And you could flip that around if you wanted. My strong recommendation is to stay on one side of the triangle when you're doing your arrows. In theory, you could say 4 is to 7 the same way 2 is to A. That will cause you a little grief more often than not. At least that's been my observation with students over the years. So now I can say, through means extremes product, that 4A is equal to 2 times 7. So if I divide both sides by 4, I know that A is 3.5. Now, this is where it gets a little tricky and where students will often make a mistake. So for part B here, I'm going to replicate the diagram quickly. I have BE is parallel to CD. They tell me AB is 4, BC is 2. I'm asked now to find the length of CD. That's an entire side. That's not one of the sides that is split proportionally. You can only use side splitter when the side is split. CD is not one of the split sides, so you can't use side splitter here. We are going to need similar triangles implies corresponding sides are proportional. AE is 7. I'm asked to find CD. So when I'm looking at this, I'm looking at triangle ABE and triangle ACD. This is my unknown. I know AC is that sum 6. I know AB is 4, and I forgot to mark the number 6 here. So now I can say 6 is to 4. It doesn't matter which way I go as long as I'm consistent. 6 is to 4, the same way B is to 6. So 4 times B equals 36, and then B is 9. That does require similar triangles because this side is not split. Please be very cautious when you're doing the problems. This is the most frequently observed error that I see on assessments. The second of the 3 new theorems reads, if 3 or more parallel lines are intersected by 2 transversals, then the parallel lines divide the transversals proportionally. So this is merely a side splitter extension. So all they've done is taken the original side splitter problem, which is in here, and extended the lines. Let's work through an example of the side splitter extension. We are told that AB, or line A, is parallel to line B, which is parallel to line C, which is parallel to line D. So they're all parallel to each other. We're given the lengths shown. FG is 5, GH is 2, HJ is 8, which makes FJ 15. We're also told that KP is 24. We are asked to find the length of KM. So I can say 5 is to 15, the same way KM is to 24. Then you could do means extremes product. I, however, notice that this can be reduced. And then 8 times 3 is 24, so 8 times 1, KM is 8. The third and final theorem for today is called the angle bisector theorem. When a ray bisects an angle, we know from chapter 1 it divides the angle into 2 congruent angles, but this is a step further. It's saying that it divides the opposite side proportional to the adjacent side. My big clue to you here is never ever cross that middle line. As long as you stay like this or like that, you'll be fine, but only go in the one direction. Either both arrows are down or both arrows are up, both arrows are left or right. In this example, we are told that RVS is congruent to TVS, and the lengths are as shown. I need to find the length of ST. So ST will be to 10 the same way 4 is to 8. And this reduces to 1/2. So ST is 5. If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.